ठीक है, राइट। अच्छा, till the last class we were discussing ring, है ना, ring in a translation motion, ring in a rotational motion, है ना, and how do we calculate work done per unit charge. अब एक बड़ा इंटरेस्टिंग क्वेश्चन सामने आता है. Suppose I take a disk, which has a uniform charge density sigma, radius r, and about the center it is rotating with angular velocity omega. And suppose he says, find the induced EMF between point A and C. And there is a magnetic field, a uniform magnetic field, say B naught minus K cap. Right? A disk uniformly charged, radius r, charge density sigma, placed in a magnetic field, uniform magnetic field, and the disk is rotating. We have to find induced EMF between point A and C. Now, my question in this is, we say that an induced EMF is generated when flux changes. अब अगर ये डिस्क अपने सेंटर के अबाउट, you remember the case of a ring, अगर मैं इसको रिंग लेता, had I replaced this disk by a ring, and I would have said कि angular velocity ओमेगा से रोटेट कर रहा है, आप बोलते सर फ्लक्स तो चेंज हो ही नहीं रहा है. And if you remember, हमने फाइंड आउट भी किया था that between any points on the circumference the net EMF is 0. अब ये डिस्क में कैसे प्रोड्यूस होगा? How do we explain this? कैसे करेंगे? आपको लगता है कि इंड्यूस EMF जनरेट होगा? एक काम करके देखते हैं. Let's do one thing. Let's take an element, a circular element. Now, in this circular element, you have positive and negative charge both. Now, when you rotate this with an angular velocity omega, the charges, the electrons will experience a negative, a centrifugal force. उसकी वजह से क्या होगा? Centrifugal force होने से क्या होगा? जो negative charge है, that will start collecting here. Yes, and the positive charge will start collecting here. And because of this, there will be an induced EMF. लिखो. So this situation is something like this, that if I take a small element of length dx, this small element, as similarly I can have a small element here, so I'll have multiple elements here. If I take this distance from the center as x and this element as dx, तो इन दो एलिमेंट्स के अक्रॉस इसका लीनियर वेलोसिटी कितना होगा? x ओमेगा, है ना? एट अ डिस्टेंस x, एंगुलर वेलोसिटी अगर ओमेगा से रोटेट कर रहा है तो इसका लीनियर वेलोसिटी कितना होगा? x ओमेगा. इसका मतलब इस छोटे से एलिमेंट के अक्रॉस एक इंड्यूस्ड ईएमएफ जनरेट होगा. वो कितना होगा? b v and similar elements I'll have at different distances. So practically अगर आप देखो तो एक छोटे से element के अंदर a small element can actually be replaced by a small battery. अब आप मुझे बताओ कि अगर ये मैंने जो छोटा सा element लिया इसको अगर मैं बाहर ले आऊं, if I were to call this element and this length is x dx and this is x omega and magnetic field is b naught minus k cap, तो जो चार्जेस का मोशन होगा, द पॉजिटिव एंड द नेगेटिव चार्जेस, उसका डायरेक्शन क्या होगा? क्या बताया था मैंने तरीका लास्ट टाइम? हाउ डू यू कैलकुलेट द डायरेक्शन ऑफ इंड्यूस्ड ईएमएफ? V क्रॉस B डॉट. नाउ इफ आई टेक दिस एज x एक्सिस, तो ये तो I कैप हो गया, B माइनस K कैप हो गया. सो व्हाट इज I क्रॉस माइनस K? J कैप. दैट मींस प्लस J के अलोंग पॉजिटिव चार्ज मूव करेगा. तो इसका मतलब क्या हुआ कि यहां पर पॉजिटिव चार्ज आएगा और यहां पर नेगेटिव चार्ज आएगा. राइट? सो on the top I'll have a positive charge. So that means this battery can practically be replaced by something like this. This small element, rotating small element, can be replaced by this. मतलब इसका EMF ये है. तो अगर मुझको सबका EMF ले ऐड करना हो तो I'll integrate this from 0 to R और L. चलो R ले लेते हैं. तो कितना आ गया? हाफ B नॉट ओमेगा. I get my point. Therefore, in certain books, they actually replace this. They say that we can actually assume a disk as infinite rotating rods, all rotating with angular velocity omega. Ab induced EMF across a rod of length R is this only. अब this will become a positive terminal, this is positive, this is negative. ये सब positive terminal हो जाएंगे. ये सब एक potential पर है. So it's a conductor. You getting my point? Therefore, अगर ये सब एक ही potential पर है, तो ये सारे की सारे batteries या सारे के सारे rods are practically in parallel. और अगर मैं same EMF के cells parallel में लगाऊंगा, the resultant EMF will be the EMF across one battery. Therefore, this becomes the answer. So that means in a disk also, you can have an EMF. Now this question can also be asked, अगर इसको छोटा question को form में लेना है, I want a 30-second answer in this. In the JEE, they can ask you that if a rod is rotating clockwise, say this is V circumference, or I can say this is VA, हमने VA लिया था और ये VC. They give you 4 options. Is VA greater than VC? Is VA less than VC? Is VA equal to VC? क्या ऑप्शन होगा आपका? इक्वल. EMF नहीं है गैस के क्रॉस. पोटेंशियल डिफरेंस क्रिएट किया ना आपने. कितना किया अभी? A greater than, because this is positively charged. They can also ask you कि अगर ये एंटी क्लॉकवाइज रोटेट करता, if this disc was rotating anti-clockwise, then what will be the case? So this is true for anti-clockwise and this is true for clockwise. तो 30 सेकंड का क्वेश्चन ये भी आ सकता है. Getting my point? छोटा सवाल भी आ सकता है, सिंपल क्वेश्चंस आ सकता है. ठीक है. Now suppose in the same question, we decide to take a situation where we have a disk again, radius is R, charge density is say sigma, and mass of an electron is small m. Okay? There is no magnetic field. And I say that this disk is rotating with a constant angular velocity omega. What will be the value of induced EMF between the circumference and the center? In this case, there is no magnetic field. So there is no electromagnetic induction. So if there is an EMF, that EMF will not be because of electromagnetic induction. Will be because of something else. Now, what is that something else? And what will be the answer? सोच के बताओ भाई EMF तभी प्रोड्यूस होगा जब चार्ज डिस्प्लेस होगा, और चार्ज तभी डिस्प्लेस होगा जब कोई फोर्स लगेगी. अब अगर वो मैग्नेटिक फोर्स है तो वो डिस्प्लेस करेगा, इलेक्ट्रोस्टैटिक फोर्स है तो वो डिस्प्लेस करेगा, या फिर सेंट्रीफ्यूगल फोर्स है वो भी तो डिस्प्लेस करेगा. तो अगर मेरे पास मैग्नेटिक फील्ड नहीं भी है और ये रोटेट कर रहा है, still there is a possibility that because of centrifugal force, charge can be displaced. So use the centrifugal force and try to find out what will be the induced EMF between these two elements, between these 2 points. So there is a displacement of charge. There's a displacement of negative charge because of centrifugal force. So the reason of producing an EMF here is mechanical reasons and not electrical reasons. क्या करेंगे? क्या करोगे? डिस्टेंस x पर सेंट्रीफ्यूगल फोर्स कितनी लगेगी इलेक्ट्रॉन पर? m. Obviously the negative charge will get displaced and the positive charge will stay there. और इसको जब ये नेगेटिव चार्ज शिफ्ट करेगा और पॉजिटिव चार्ज रह जाएगा तो एक इलेक्ट्रिक फील्ड क्रिएट होगा, और वो इलेक्ट्रिक फील्ड इसी इलेक्ट्रॉन पर ऑपोजिट डायरेक्शन में फोर्स लगाएगा. भाई अगर मैं मानूं कि ये पॉजिटिव चार्ज नेगेटिव चार्ज यहां पर आ गया और पॉजिटिव चार्ज यहां पर आ गया, अज्यूमिंग, तो क्या होगा? एक इलेक्ट्रिक फील्ड ऐसे प्रोड्यूस होगा, यस और नो, और नेगेटिव चार्ज पर वो फोर्स नीचे लगाएगा. तो इसका मतलब इलेक्ट्रॉन पर एक सेंट्रीफ्यूगल फोर्स ऊपर लग रही है और इलेक्ट्रिक फोर्स, and there'll be a time that they'll balance out each other. There will be an equilibrium, which means this will be equal to इस डिस्टर्बेंस की वजह से जो इलेक्ट्रिक फील्ड प्रोड्यूस होगा वो इलेक्ट्रिक फील्ड भी इस चार्ज पर एक फोर्स लगाएगा. So that means there are practically two forces acting on this charge. One, centrifugal force, electric field has got produced, and that electric field will apply a force on this electron in the opposite direction, and when they become equal, this will be the situation. So I can write this as this also. Our electric field होता कितना है? Minus dV by dx. It will be mx omega square by E, which means dV will be minus mx omega square dx upon E. I have to integrate this from 0 to है ना जी? Yes, girls? So solve it. Complete करो. वो तो गया, कितना हो गया जी? m r square m, absolutely perfect. ठीक है, let's take another situation. What we are discussing in these classes are practical possible situations which can be asked in the entrance exam. Now suppose we have a situation like this. Last time मैंने भी non uniform मैग्नेटिक फील्ड में भी हमने निकालने की कोशिश की थी इंड्यूस्ड ईएमएफ इन अ लूप निकाला था, इन अ सिंगल करंट कैरिंग कंडक्टर, इन अ कंडक्टर वो भी निकाला था हमने. अभी सिचुएशन देखते हैं. बनाओ, एक करंट कैरिंग एलिमेंट है, two semicircles form a waveform. The angle it makes with the x-axis is theta. The whole thing translates with velocity v. यहां से डिस्टेंस d लिया है और ये करंट कैरिंग कंडक्टर है. हमको पॉइंट A और पॉइंट C इन दोनों के बीच में इंड्यूस्ड ईएमएफ निकालना है. What will be the approach? कर 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 ठीक ठाक से चाय बहुत जहरीली चाय मत पिलाओ. अच्छा एक बात बताओ, मुझे एक इस क्वेश्चन में दिख क्या कह रहा है? एक तो ये दिखाई दे रहा है इट्स अ नॉन यूनिफॉर्म फील्ड बिकॉज ऑफ दिस करंट कैरिंग कंडक्टर. इमेजिन करते हैं लास्ट क्लास में मैंने डिस्कस किया था, इफ आई हैव अ करंट कैरिंग कंडक्टर एंड देयर इज अ कंडक्टर लाइक दिस, लेंथ L, let's take this distance as say A, and it is moving with velocity v. हमारा आइडिया क्या था इस क्वेश्चन को सॉल्व करने का? हाउ वर वी अप्रोचिंग दिस प्रॉब्लम? बी एवरेज. हमने इस रीजन में इस नॉन यूनिफॉर्म फील्ड को एक यूनिफॉर्म फील्ड में कन्वर्ट किया था, राइट? कैसे? बेसिक इसका लॉजिक क्या है? इफ आई टेक अ स्मॉल डिस्टेंस फ्रॉम हियर, आई टेक दिस एज x and this as, and move it with velocity, इसके क्रॉस इंड्यूस्ड ईएमएफ कितना जनरेट होगा? बोलो. म्यू नॉट अपॉन 2 पाई I by x into dx into a small potential difference here. And if I integrate this from A to A plus L, I'll get the required EMF between these two terminals. Now, if I want to calculate the direction of induced EMF, then क्या बताया, तरीका बताया था? V cross B. V is J. B is minus K. So what is J cross minus K? Minus I. Minus I? Minus I? तो ये minus I आ गया. तो उसका क्या मतलब हुआ? नेगेटिव चार्ज इधर आएगा या नेगेटिव चार्ज इधर आएगा? Will the positive, will this terminal A be positive or A will be negative? कैसे? आपने क्या लिखा है अभी? V लिया आपने J cap. V cross B. What is V cross minus K? Minus I. Which means the positive charge will move towards the negative x-axis, which means यहां पर positive charge होगा और यहां पर. Situation 1. Situation 2 could be क्या और एक इंटरेस्टिंग सिचुएशन लेते हैं. Okay, let's take it like this. This distance is d. This current carrying conductor is I. And I'm moving this with velocity v. अभी क्या करेंगे? क्यों? क्योंकि मेरा v क्रॉस b डॉट dl है. इसका मतलब यह हुआ कि अगर मैं ये एज्यूम करूं कि इस कंडक्टर को, इफ आई वर टू रिजॉल्व इट इनटू टू डायरेक्शंस, दिस and remove this, call this as L cos theta, and this is, this conductor would be moving like this and this conductor will be moving like this. Now motion of this conductor will cause no harm, will produce no change in flux. Yes, but the motion of this conductor will definitely cause a change. So instead of L, what would I use? A यहां से यहां तक, A to A plus. So this could be case 1, this is case 2, and this is case 3. Now if you compare this with this, से भी होगा ना, हम क्या करेंगे? ये लेंथ कितना हो जाएगा? ये लेंथ कितना हो जाएगा? ये लेंथ कितना हो जाएगा? दिस डिस्टेंस, अच्छा ये मैंने कहां से मेजर किया? सेंटर से, है ना? बोलो, रिस्पॉन्ड. ये डिस्टेंस कितना होगा? और नीचे वाला ये इंटीग्रेट करना है ना लिमिट्स में, एंड द सेम थिंग कंप्लीटली. Yes or no? बस करो, इसमें डाला ही नहीं। क्या स्लाइड चला दे। ये कर लिया था, नेक्स्ट आगे चलो आगे, और ये भी कर लिया था, नेक्स्ट ये भी हो गया था, ये भी कर लिया था, यस नेक्स्ट ये भी हो गया था, नेक्स्ट ये भी हो गया था, ये भी कर लिया था, यस आई लाइक इट। नेक्स्ट क्वेश्चन, सिचुएशन, नेक्स्ट सिचुएशन क्लियर है ना जी? Let's see the situation. This is a conducting ring, a fixed conducting ring. This is a rod of length R. This is a resistance which is fixed. These 2 points are fixed. Now what we do is we start rotating this rod with a constant angular velocity omega, and a magnetic field is there inside this ring. We have to find out what is the current in the loop. इस loop के अंदर current कितना flow करेगा? क्लियर हो गया क्वेश्चन? अच्छा देखते हैं। ये भी ध्यान रखना, इसका रेजिस्टेंस भी स्मॉल आ रहा है। The rod also has a resistance small r. क्या आंसर आ रहा है? अच्छा, let's see. First of all, there will be an induced EMF between these 2 points. कितना होगा? Induced EMF between AC. B omega. सब लोग बोलो. Number one. Number two, the terminal A, will it be at a higher potential or a lower potential? Higher or lower? Confident? That means I can replace this. Make sense? This does not have any resistance. This does not have any resistance. Therefore, these 2 points are at the same potential. Same situation is with this. So this is the EMF. Internal resistance small r. External resistance capital R. तो ये पॉइंट मैंने यहां कनेक्ट कर दिया, ये पॉइंट यहां कनेक्ट कर दिया. अब मैं इसको हटा सकता हूं. मैं इसको ऐसे भी लगा सकता हूं. अब मैं इसको यहां से भी हटा सकता हूं. तो ये सर्किट ऐसे हो गया ना. सो आई का वैल्यू कितना हो गया? व्हाट इज द वैल्यू ऑफ आई? ये पॉजिटिव टर्मिनल हो गया, ये नेगेटिव टर्मिनल हो गया, ये इंटरनल रेजिस्टेंस है, ये एक्सटर्नल रेजिस्टेंस के अलावा कुछ है ही नहीं. करंट तो इसी सर्किट में फ्लो करेगा ना. हाँ क्या है? क्या है? Yes, I can hear you. I can hear you. This question? Okay. Now listen. The question is that there is a conducting ring. There a rod is connected between the center and the circumference. This end is fixed and this rod can rotate, this rod can slide on the circumference. The length of the rod is L and the internal resistance of this rod is small r. There is a fixed resistance capital R which is connected between these two terminals. And there is a magnetic field along negative Z axis. Now, what I'm suggesting is that once this rod starts rotating in a magnetic field, there will be an induced EMF between these 2 points. We've discussed this. The value of induced EMF will be B omega L square by 2. Since we also know that this terminal will be positive terminal and this will be the negative terminal. So I can practically replace this rod by a battery whose EMF is B omega L square by 2. The positive terminal will be here, the negative terminal will be this side, and it also has an internal resistance small r. That small internal resistance is here. This capital R resistance is. Now, since these 2 points lie on a conducting surface or a conducting ring, and similarly these 2 points, this point and this point, also lies on the conducting ring, That means these two are at the same potential. So I can simply connect them with assuming them to be a zero resistance wire like this. Now, yes, because this point, between these 2 points, there is no resistance. So IR is 0. You know? When there is no R, then I into R becomes 0 and they become same potential points. Potential difference only takes place between a resistor. You say there is a potential difference across a resistor. But if there is no resistance, then there is no potential difference. There can be current in the element, but if there is no resistance, you don't have a potential difference. You can have current, but not necessarily potential difference. So when there is no potential difference, it means they're at the same potentials. They're at the same potential points. So you can actually connect them with a single wire. Now, this is the EMF. These are the two resistances. They are in series. Therefore, the current in the circuit will be B omega L square by 2 into R plus R. Clear? Very good. Next question. Oh. Next question देखना. उससे और मजा आएगा करने में आपको. नो, ये नहीं है. इससे पहले क्या है? चलो मैं एक और क्वेश्चन ऐड करता हूं. सो जा तो पहले. ठीक है. Same conducting ring. Instead of one rod, now you have two rods. Length L, internal resistance small r, same question. Magnetic field B minus K cap, and an external resistance capital R. Perfect. दोनों same angular velocity in the same direction are rotating with same angular velocity. Instead of one rod, there are two rods. You have to tell me what is the current in this resistor. सोच ठाकुर. पहले इक्विवेलेंट सर्किट बना, तब खेल का मजा आएगा. First draw its equivalent circuit. Then this question will make sense. क्या से बोला तूने? ठीक है. Very good. बढ़िया. ये तो बैटरी हो जाएगी ना. एक बैटरी हो गई, एक बैटरी हो गई. ये एक हो गई, ये दोनों हो गई, दोनों पैरेलल में होंगी. इन दोनों का ये पॉइंट कॉमन है, ये पॉइंट भी कॉमन है. ठीक है. और ये वाला पॉइंट इससे कनेक्टेड है पॉजिटिव टर्मिनल से, और ये टर्म पॉइंट नेगेटिव टर्मिनल से कनेक्टेड है. ठीक है, राइट राइट, स्मॉल r इंटरनल रेजिस्टेंस विल, अब देखिए, कंफ्यूजिंग योरसेल्फ इन दिस सर्किट. This circuit can be redrawn like this. देखा क्या कर रहे हो, ये आपने अलग अलग कैसे कर दिया. How can you dissociate these two circuits? They're part of one single circuit ना, सिंगल सर्किट बनाओ. आप देखो क्या कर रहे हो, एक ही बैटरी थोड़ी है. अभी दिखा दे जरा, अभी तूने ये वाला पार्ट किया है, अब इसको इधर लेके आ, सिम ऐसे होगा ना, ये बनेगा. क्या है मुझे बताओ, क्या है, अच्छा सवाल है क्या. दिस वन, अभी रुक जा ना, करंट डिपेंडेंट करंट करेंगे, अभी रुक जा, सब हो जाएंगे. बाय. करेक्ट, सबने कर लिया ना. डेली रॉक्स क्या बनाएगा, the equivalent circuit for this would be and the equivalent circuit for this yeah, where the value of E is V care, absolutely. Next slide दिखाना यार. I think we did this question last time. A single conducting ring, disk sliding with a constant velocity v, निकाल लेंगे ना इसको. I just now told you that you have to, in a disk, convert them into rods. And we know how does a rod behave when it moves in a translational motion. Agreed? Next. One of my favorite questions. I really like this question. Try kariye. I'll tell you. It says that there are 4 rods. हर रॉड का रेजिस्टेंस पर यूनिट लेंथ इज लैम्डा. There is a uniform magnetic field directed inwards. The initial length is L, the rod's initial length. Then they decide to move with the same velocity towards each other. You have to find out the induced EMF in the circuit and the induced current in the circuit with its direction. The first thing you have to do in physics is to visualize the situation. पहले आप इसको visualize करो, हो क्या रहा है, करो. अच्छा, अगर ये कहता है इन दिस क्वेश्चन, sometimes language of the question decides the progress of the question. Sometimes, like for example, there are certain things which are not given in this question. He does not specify what is the situation of these rods at t equals 0. नहीं पता ना? But he's asking find the values as a function of time t. That means we have to define t equals 0. Now, logically, if t equals 0 is not defined or is undefined, then definitely we will assume that at t equals 0, the individual length was L. ले तो कैसे करेंगे भाई? एक इंडिविजुअल लेंथ L गिवन है, एक वो कह रहा है किसी फंक्शन टाइम t के हिसाब से निकालो, तो आपको ये तो अज्यूम करना पड़ेगा ना कि इनिशियली इनके कॉर्नर्स एक दूसरे को टच कर रहे होंगे, सबका इंडिविजुअल लेंथ L होगा. ठीक है, अब I have to consider each rod independently. That's I have done. अब तक जो मैंने क्वेश्चन सॉल्व किए, in that we had a uniform magnetic field and a rod of a certain length traveling with a certain velocity, and we were able to find out the induced EMF. Now the problem in this is that when I want to find out induced EMF between these two terminals, suppose जब मैं इन दो के बारे में बात करूंगा तो ये भी इसकी तरफ मूव कर रहा है, जब मैं इसकी बात करूंगा तो ये इसकी तरफ मूव कर रहा है. बिकॉज जब ये मूव करेगा तो इसके मूव करने से इस लेंथ पर ये जब मूव करेगा आगे, मुझे बताओ कि इन दोनों इस रॉड के मूव करने से बाकी किस रॉड के ऊपर इफेक्ट आ रहा है, या बाकी किसी और रॉड के मूव करने से इस लेंथ पर डायरेक्ट इंपैक्ट किसके ऊपर आएगा? कौन सी? पैरेलल. क्यों? हाँ, मतलब व्हाट आई एम सेइंग इज कि सपोज मैं डिसाइड करता हूं कि टाइम t इक्वल 0 पर ये लेंथ L है. अब ये लेंथ रह कितनी गई? हाउ मच इज दिस लेंथ? v इसने मूव किया, v इसने मूव किया. हाँ या ना? यस और नो? That means effectively my length is L minus 2 VT. Now, इससे चलो ये तो फटाफट बताई दो, ये टर्मिनल बड़ा होगा, A will be and this will be. तो इसके क्रॉस the potential difference across this will be, बोलो, B V. देखो, in physics, even if you do not know the question and you have a common sense and you are able to visualize the question properly, you can solve it. Mathematics may, if you have a question in definite integration and you don't know the formula, you can't proceed further. In chemistry, if you forget the formula, whether it is electrochemistry or it is organic chemistry, forget about inorganic में तो सभी कुछ याद ही करना है, आप proceed नहीं कर सकते. इसीलिए generally the students who get very good marks or are the toppers, the physics is amazing. और physics को amazing करने के लिए कुछ नहीं करना, सिर्फ शांति से चीजों को visualize करना है. सब सारी चीजें सामने तो हैं, they're all in front of you, just visualize them. अब मुझे बात बताओ, ये जो रॉड मैंने ऑन द लेफ्ट हैंड साइड ली है, इसकी बात करिए ना. अब इसके नीचे वाला एडजेसेंट रॉड की बात करते हैं, ऑब्वियसली वो भी L minus 2 VT होगा. मुझे बताओ डायरेक्शन ऑफ ईएमएफ क्या होगा? व्हाट विल द डायरेक्शन ऑफ ईएमएफ? आई मीन इफ आई टेक A was positive, C was negative. Now if I were to consider CD, which will be positive, which will be negative? जरा सोच के बताओ. चेक कर लेते हैं, लड़ना मत शुरू करो प्लीज बहनों. ये V J क्रॉस माइनस K कितना हुआ? माइनस I. इसका मतलब है ना, तो ये कुछ कहानी ऐसे बन गई ना, all the EMFs will be same. हाँ, कहाँ है? You know, you are my favorite student. Ask me why. तेरे को मेरी आवाज ही सुनाई नहीं दे रही? Can you hear me? I said you are my favorite student. Yeah. And I'll tell you why. Yes, I'll tell you why. Because you don't move forward till the time your doubts are cleared. Number one. Number two, you don't hesitate. You're a fearless girl. Be like this all your life. Be like this, fearless. Now, one of my students will explain this. आजा, L minus 2 VT क्यों था? मेरे बच्चों के डाउट्स मेरे बच्चे डाउट्स दूर करेंगे. ये ले माइक.
ये वाली लेंथ कंसिडर कर रहे हैं हम AC लेंथ कंसिडर कर रहे हैं. पहले लेफ्ट हैंड साइड वाली, ये इधर से मूव कर रहा है V, ये इधर से मूव कर रहा है V. हम लेफ्ट हैंड साइड वाली,
हाय फ्रेंड,
हम लेफ्ट हैंड साइड वाली रॉड कंसिडर कर रहे हैं AC, जिसकी इनिशियल लेंथ L थी. ये वाली जैसे रॉड V मूव कर रही है, ये वाली भी V मूव कर रही है, तो इसकी न्यू लेंथ हो जाएगी L minus 2V. इसका डिस्टेंस और टाइम T तो 2.
ऐसे बताना ये लेंथ कितना है?
L.
ये कितना मूव किया?
V.
ये कितना मूव किया? नया लेंथ कितना हो गया? क्लियर? The length was L. Now this rod, it was like this. All L. Okay. I'm worried about this length. Now in time T, this rod has traveled VT. In time T, yes, this rod has traveled VT. So what is this length left now? 2 VT. So you're a rock star. Good. Keep it up. Yes. I can always hear you. Yes, you can. I just call the most appropriate person. Please come. इधर आइए, आइए. Can I give it? Okay. Dear, with the permission of CBSE, I am giving you my email ID. It's Sandeep_4@yahoo.co.in. Can you see? Sandeep underscore 4 at yahoo.co.in. Yes. Yes. डबल्स तो है ही, डबल तो सब कुछ ही है, तो ई डबल तो हो गई. एंड सी also simultaneously, since I am a consultant to the CBSE, you can simultaneously post your doubts at the helpline also. Do you have the helpline number? करवाली बेचती, ऐसा नहीं है, मैम कह रही है आता है, हाँ लेकिन डिले हो जाता है. ऐसा है कि थोड़ा सा प्रॉब्लम था, वो दूर हो गया है. नाउ यू विल हैव रेगुलर आंसर्स टू योर क्वेश्चंस. आप मेरे को ईमेल आईडी पर करिए इस पर. आई प्रॉमिस यू विद इन नेक्स्ट 24 आवर्स इज द मैक्सिमम टाइम you will have the answer to your question. बेटा आप कभी भी भेज सकते हो, any time of the day or night. Within 24 hours, I will give you a solution and the answer to that problem. ठीक है? It's a आपका नाम क्या बेटा? Oh, so nice of you. Yes. Thank you. Okay, thank you. Right. अच्छा क्वेश्चन था ना? Nice problem. Next slide. ये तो हम कर लेंगे. इसके तो अच्छा सुनो, listen. See the first question. A metal rod length L rotates about end. A uniform magnetic field B exists in the direction. Calculate the EMF induced. आज किया हमने. A rod length rotates with a small but uniform angular velocity omega perpendicular to the bisector. A uniform magnetic field. Find the potential difference निकाल लेंगे हम. हो जाएगा ना? Same question, बिल्कुल similar question. Next. Nice question. Okay, now I'll explain you. पहले आप क्वेश्चन पढ़ लो. हेल्पलाइन के क्वेश्चंस के आंसर आते हैं. क्वेश्चन नहीं रखा है. They have a question. चलो एक इंटरेस्टिंग थॉट शेयर करते हैं आज आपसे. तैयार हो? एक सिचुएशन देखते हैं. We are discussing now the work energy theorem in electromagnetic induction. ये बहुत ही इंटरेस्टिंग थॉट है, जरा देखिए ध्यान से. Till now, what we have done in EMI is we know that electromagnetic induction में जो current produce होता है वो non-conservative behavior का होता है. Induced EMF is non-conservative in nature. Then एक तरीका induced EMF generate करने का सीख लिया हमने कि अगर यूनिफॉर्म या नॉन यूनिफॉर्म फील्ड में एक कंडक्टर को मूव करते हैं तो इंड्यूस्ड ईएमएफ कैसे प्रोड्यूस होता है. अब इसका थर्ड एस्पेक्ट है क्या. When I say that it is moving with constant velocity v, ये क्या constant velocity v से मूव कर सकता है? नहीं कर सकता है. Because you know it कि if at an instant v, at a certain instant say t equals t, the velocity of this rod is v, then induced EMF across this will be BVL. If the resistance is R, then the current will be BVL by R. If there is current and there is magnetic field, it will experience a magnetic force, and the magnetic force will be backwards, and that will reduce this velocity definitely. That means if I'm saying that it is moving with a constant velocity v, you're applying external force. अब देखते हैं how many types of forces and how many types of work done are possible. Like for example, मैं अगर आपसे बोलूं, let's first find out work done by the magnetic force to start with, Fm. क्या लिखोगे आप? और वर्क डन पर यूनिट टाइम अगर निकालूं तो इजी हो जाएगा. क्या लिखोगे आप? The magnetic force is backwards, the velocity is forward, therefore there will be a negative sign. I'm using the term called direct power. निकाल लेते हैं. इनटू टाइम करना होगा अगर तो उसको मैं dt से मल्टीप्लाई कर दूंगा. ठीक है. Now let me find out work done by the external force Ex, Fe. क्या लिखेंगे? Work done per unit time. There is another loss here. That means loss of work or loss of energy or loss of power in the external resistance. वो कितना है? I कितना होगा? ये कितना हुआ? ये लॉस है. ये कितना होगा? Fm will be BIL into V. BI will be ये मुझे पता नहीं है. मैग्नेटिक फोर्स का वर्क डन, एक्सटर्नल फोर्स का वर्क डन, उधर एक लॉस भी मैंने दिखा दिया. आपको लगता है कि इसके अलावा इज देयर एनी अदर वर्क डन आल्सो व्हिच आई हैव मिस्ड आउट? एक्सटर्नल, मैग्नेटिक, लॉस. कोई और भी है वर्क डन? ये सब तीनों we have taken all of them, or is there we are left with some other work done? Gravity nahi hai. It's in a horizontal plane. Assuming it is in a horizontal plane. Now there is 1/4 work done also, which till now I haven't seen in any book. मैंने अपनी किसी भी किताब में आज तक चीज देखी नहीं है. एक फोर्थ भी कंपोनेंट है. बताओ आपको कौन सा कंपोनेंट है फोर्थ? ये यहां पर प्रोड्यूस क्या हो रहा है फाइनली? एक बैटरी प्रोड्यूस हुई है ना. दिस EMF across this rod is equivalent to, और एक पॉजिटिव चार्ज यहां से मूव कर रहा है ना. When this charge moves across this battery, the battery will also do some work. तो work done by battery कितना होगा? Charge. And this work done will be positive because a positive charge is coming out from a positive terminal. Work done by battery is potential difference into charge. Charge है Q, potential difference है BVL. ये work done हुआ ना. और per unit time ले लूंगा इसको मैं, तो ये हो गया BVL I. BVL upon R. B square V square L square by R. ये पॉजिटिव होगा. अब जरा देखना ध्यान से. ये मैग्नेटिक फोर्स का वर्क डन ये था ना. ये एक्सटर्नल रेजिस्टेंस के क्रॉस लॉस है. ये बैटरी का वर्क डन है, और ये एक्सटर्नल फोर्स का वर्क डन, which I'm still, I don't know what the work done is. But I know one thing for sure, that this velocity remains constant. If velocity is remaining constant, that means there is no change in kinetic energy. That means the total work done has to be 0. Note karo. Now, as we come closer to your exams, एक बात मैं तुमको और clear कर दूं. Once we finish this, I'm going to have request UDAAN team to give me a 3-4 hour big slot to revise whatever we've done till now. I'm going to start from electrostatics and take you to EMI and solve only advanced level problems. उसमें आप वो टॉपिक पहले से तैयार करके आओगे. Then I'll give you a follow-up test. Then this lecture will be complete. अभी क्या है कि fragmented है. I taught you, you're writing a test, but I will prepare one test for you. पहले से कर लेते हैं EMI तक. Because before I start optics, you're going to love optics the way I teach optics. You're going to really love it. We use no formula in solving optics. No sign convention, no formula. So I want to complete this till EMI. Then we have a big class. We revise everything. Follow-up test. Then this topic will be consolidated. And I'll see that when these questions come in your exam, and if you're not able to solve it, then I'll take this ownership completely. फिर मेरी जिम्मेदारी होगी कि एग्जाम में अगर ये सवाल आया और आपने सॉल्व नहीं किया, तो फिर इसका मतलब 17 साल मैंने कुछ नहीं करा. इससे मैंने 17 साल सिर्फ घास काटी है. बट प्रोवाइडेड एक रिविजन क्लास फॉलोड बाय एडवांस लेवल टेस्ट व्हिच आई विल प्रिपेयर. ठीक है, ऑल सेट. तो अभी हम दोबारा करेंगे इलेक्ट्रोस्टैटिक्स में. देयर आर फ्यू थिंग्स व्हिच वी स्किप्ड, लाइक फॉर एग्जांपल अर्थ मैग्नेटिज्म मैंने आपको कराया नहीं है अभी, जान पूछे छोड़ा हुआ है मैंने उसको, क्योंकि वो कंपोनेंट ग्रेविटेशन से रिलेटेड है. So when I revise your gravitation, I'll take your Earth's magnetism. Are you getting my point? चलिए. हाँ बिल्कुल श्योर वही है क्या? मैं बोल दूं? I will discuss. I'll do one thing. After completing till EMI, I will ask you all the doubts you have in all the topics from electrostatics till EMI. I'll take those doubts first online. Then I will review the entire syllabus my way, those 4-5 chapters, and then give you a follow-up test. ये complete होने के बाद तब ये topic अपना complete होगा. Okay? Don't worry. वो डिसाइड हाँ, वो डिसाइड करके बताएंगे आपको कब होगा एग्जैक्टली। ओके, थैंक यू। अब देखना है सारे के सारे वर्क डन है, ठीक। नेट वर्क डन शुड बी, अब जरा देखना, मैं एक काम करता हूं, इस वर्क डन को, इस पावर को इससे काट देता हूं, दोनों सेम है ना। क्या बचा मेरा, पावर ड्यू टू एक्सटर्नल फोर्स इक्वल्स लॉस ऑफ power at the resistance. देख ले, ये बचा ना, एक तरह ये कंपोनेंट बचा, एक आपका ये वाला कंपोनेंट बचा। क्लियर? अब इस क्वेश्चन को देखो आप, read this question now. I've seen this is a JEE problem, and in most of the books I've seen this problem being solved in more than half a page. मैं चाहूंगा मेरे बच्चे इसको 1 मिनट में सॉल्व करें, लेस देन अ मिनट। रीड करना, वर्टिकल रेल्स लिख लिया, आर यू डन विद दिस? लिख लो उसको प्रॉपर्ली, लिख लो, नो हरी, कोई जल्दी नहीं है। बट ये वाला देख, मैंने वर्क डन बाय बैटरी निकाला या पावर वर्क डन पर यूनिट टाइम, दिस इज इक्विवेलेंट टू अ बैटरी and there is a charge which is flowing through the battery, so the work done is Q into BVL. By time this becomes I. वैसे वो जो स्टूडेंट अभी बोल रही थी कि उसके डाउट्स दूर नहीं होते हैं, the helpline of CBSE is working 24 hours, and believe me, it is not easy to get hold of all the problems at one time, but still they are working overnight. They work all the day, all the night, so that you get satisfied. Still, if there is any problem, the helplines are always available. ठीक है, ये clear है? Now let's read this question carefully. It says, it's a beautiful question, my favorite. Two resistances, metallic system. It's a metallic frame in a vertical plane, so gravity is acting. So it says two parallel metallic rods A, B, C, D are separated by 1 meter. Great. That means the length of the rod is 1 meter. They're connected end to end by resistance R1, R2. Slide without friction under vertical. There is a uniform horizontal magnetic field of 0.6 Tesla. Perpendicular to the plane of the rails. इसको हटा दो, ठीक है। It is so that when the terminal velocity is attained, होने दो, terminal velocity means constant velocity. अच्छा, ये जो रिजल्ट मैंने निकाला है, ये किसके लिए निकाला है? When? Absolutely. अब एक स्टूडेंट मुझसे पूछता है, सर अगर वेलोसिटी कांस्टेंट नहीं होगी तो क्या करेंगे? पूछो आप भी, क्या करेंगे? हवन करेंगे, देखते क्या होता है। अच्छा बात बताओ, वर्क एनर्जी थ्योरम क्या बोलती है अपने को कि नेट वर्क डन, राइट? ये जो मैंने टोटल पावर निकाली है, ये ऐसे है ना, पावर ड्यू टू एक्सटर्नल प्लस पावर इन आई स्क्वायर आर इज इक्वल टू, पावर है ना, आई कैन राइट डी बाई डी टी हाँ या ना, बोलो। तो अब अगर ये चेंज जीरो है तो ये जीरो था, और अगर ये नहीं है तो ये होगा। नहीं होगा तो फिर ये होगा, देख लो। परफेक्ट। अब इधर चलते हैं। तो इसका वी कैन, आई थिंक वी कैन सॉल्व इट इन वन लाइन। यहां पर एक्सटर्नल फोर्स कौन सी है? mg, ग्रेविटी। टर्मिनल वेलोसिटी vt, ये पावर हो गई। ये किसके बराबर होगा? Now he says it is observed that the terminal velocity is attained, the power dissipated across r1 and r2 are this and this. तो नेट पावर कितनी हो गई? 1.92 है ना? m कितना है? g ओवर एंड आउट। अब मैं आपको बताता हूं ये बुक्स में सॉल्व कैसे होता है। वो भी सुनना चाहते हैं आप? अभी वो बताते हैं आपको, देखिए। मेरी तो देख लो यार, मैं समझा रहा हूं। लेंथ गिवन, v गिवन, लोग निकालते हैं बीवीएल, फिर इसमें करंट, फिर इसमें करंट, फिर इसका आई स्क्वायर, फिर इसका आई स्क्वायर, फिर ऐड। भगवान जाने क्यों। इंटरेस्टिंग लगा आपको? So this was a subjective question which came in IIT, and you girls could solve it in 30 seconds. I'm so happy. Next question, please. I like it. पहला क्वेश्चन आपको मिलता है 1 मिनट, दूसरा क्वेश्चन आपको मिलता है 2 मिनट। 3 मिनट के अंदर आपको दोनों सवाल सॉल्व करने हैं, एंड योर टाइम स्टार्ट्स नाउ। मैं आपकी हेल्प कर दूं रीड करने में? मना नहीं करते ये लोग। हाँ हाँ सर, फ्री में दे रहे हो, कुछ भी कर दो, सादा की जा रहा है। ये टेबल है, टेबल। रोप स्मॉल m, रेजिस्टेंस बिटवीन द डिस्टेंस बिटवीन द रेल्स L, तो रॉड लेंथ L मिल गया आपको। फ्रिक्शनलेस सरफेस, अ कंडक्टिंग मासलेस रॉड ऑफ रेजिस्टेंस, इसकी कैपिटल रेजिस्टेंस R दे दिया। ठीक है, उल्टा हो गया ना? ये इधर होता, एक्चुअली देखा जाए तो होना ये चाहिए था। चलो एनीवे, इसने ये इसको फिक्स कर दिया। इनिशियली हम क्या करते थे, इसको रॉड लेते थे, यहां रेजिस्टेंस लगाते थे, तो इसने इसको फिक्स कर दिया फ्रेम को, तो इसी का रेजिस्टेंस है R है और इसी का लेंथ L है। एक पुली लगा दी, पुली के साथ आप नीचे खींच रहे हो, देयर इज अ कांस्टेंट मैग्नेटिक फील्ड परपेंडिकुलर टू द टेबल, सिस्टम इज रिलीज फ्रॉम रेस्ट, व्हाट इज द टर्मिनल वेलोसिटी? चलो 30 सेकंड स्टार्ट करो। बोल दो आंसर। चलो मचाते हैं, क्या बोलते हैं? mg and I will be ये vt हुआ ना? Second part, 1 minute. अभी क्या बोलता है, अगर इसका वेलोसिटी इज हाफ द वेलोसिटी, मतलब इसका वेलोसिटी वाज टर्मिनल वेलोसिटी ना, अगर इस मास का वेलोसिटी इज हाफ द टर्मिनल वेलोसिटी, so what will be the acceleration of the system? Hello, what is this? Acceleration. यहां क्या सब्स्टिट्यूट करना है, vt बाई vt आपके सामने है. क्या हुआ, हो गया ना, डायरेक्ट खत्म. एक क्वेश्चन और करते हैं, and then next class के अंदर I'll take up the third component of EMI, which is how does induced electric field produced due to a time varying magnetic field. अभी तक हमने किया है डिस्टेंस वेरिंग मैग्नेटिक फील्ड, बाद में करेंगे टाइम वेरिंग मैग्नेटिक फील्ड. एक क्वेश्चन और लेते हैं. दिस प्रॉब्लम केम इन Xii 1998. He says resistance per unit length. पूरा बताऊं क्वेश्चन क्या है. Two parallel horizontal rails, two long parallel horizontal rails, that means these becomes the rail, separated by a distance small d, having resistance lambda per unit length. ठीक, तो जो लेंथ है वायर का, ये कंडक्टिंग रेल्स का, ये रेजिस्टेंस लैम्डा पर यूनिट लेंथ है. द मास ऑफ दिस रॉड इज स्मॉल m, and we are applying a constant force F on this rod. It's not constant, it's variable. A variable force F is applied on the rod such that a constant current flows through the resistor. So we have to find the velocity of the rod as a function of F. Or you can say we have to find the relation between Vf as a function of x. We can measure x from this distance. So he says I is constant. And we have to find a relation between f and v as a function of x. So I think since the time is over for this class, we can discuss this in the next class. तब तक आप सोच के आना. And for your reference, this problem came in Xii 1998. Sorry, 1988. So if you want to refer, you can also refer. तो आपसे मुलाकात होती है next week, same time. Take care.
Hello students, today we'll be taking up the topic maxima and minima. Maxima, minima of a function. Now first thing is, you must know when there is a function y equal to fx and it is defined in a domain, it is a continuous function, what are its critical points? Let us take these concepts one by one. I want one of you to tell me what are the critical points of a function. Slope is 0 means, what is slope? Slope of a function at a particular point is derivative at that point. So critical points are where dy by dx is equal to 0 or it does not exist. This is very important. Generally, students think that where derivative is vanishing, those are the critical points. But besides this, where derivative does not exist, those are also the critical points. Like for example, if we take a curve, like you can say mod x. You know the shape of mod x? Y equal to mod x, right? X is equal to y equal to x when x is positive, and y equal to minus x when x is negative. Now in this case, you will find that there is no point where the derivative is becoming 0. Derivative is not vanishing at any point because the derivative will vanish only at those points where the tangent is parallel to x-axis. Like if you consider this curve, now here you have got 3 points where the derivative is becoming 0. Why these are the points where derivative is becoming 0? X is A, X is B, and X is C. Why these are the points where the derivative becomes 0? Because at these points, the tangent line is parallel to x-axis. And when the tangent line is parallel to x-axis, the angle which this tangent makes with positive direction of x-axis is 0 degrees. So what is tan 0? 0. So the slope is 0. But in this case, y equal to mod x, you will find that there is a point where the derivative does not exist. Which is that point where the derivative does not exist? It is x equal to 0. This is known as a sharp point, and at this point we cannot draw a unique tangent. A unique tangent cannot be drawn. Therefore, this is the point where the derivative does not exist. So what are critical points? Critical points are the points where the derivative either becomes equal to 0 or the derivative does not exist. So this you must know, because when we have to find points of maxima minima, we observe the critical points, not just the points where the derivative will vanish. Besides that, we'll also look at the points where the derivative does not exist. So if you look at this function y equal to mod x, you will observe that x equal to 0 is a point of local minima. Because see, what is the lowest value which the function mod x takes? Y equal to mod x? 0. Because everywhere the function is positive. So 0 is a point of minima. It is the point of local minima as well as it is a point of absolute minima. Because if you consider the full domain D, all real numbers, at this is a point where the value of the function is 0 and at no other point it is 0. At all other points it is positive. So it is absolute as well as local. Local we just see in a neighborhood. We see just in the vicinity or in the immediate neighborhood of the point. But you can have points of local maxima minima which are also points of absolute maxima minima. That is possible, right? So now you are clear with what are critical points. Critical points are the points where, if you consider this function y equal to fx, x equal to, critical points are those points where the derivative is 0 or derivative does not exist. Does not exist, you can use this symbol or you just write does not exist. Right? So f be a real valued function with domain D, x equal to a is said to be a critical point where f dash a is 0, where the derivative is 0, or f dash a does not exist. Now all of you just try and find out the critical points of this function. What are the critical points of the function which is mentioned here? X minus 2 raised to the power 2 by 3 multiplied by 2x plus 1. Suppose examine this function for maxima minima. What points we should take? First thing is you will find the critical points. Now this is a function fx is equal to x minus 2 raised to the power 2 by 3 multiplied by 2x plus 1. Now to find critical points, we'll first find the derivative, right? F dash x is equal to I'm differentiating the first, second as it is. Now simplify this. Right, so this will come out to be derivative is coming out to be twice of 5x minus 1 upon x minus 2 raised to the power 1 by 3. Right? Now who will tell me what are the critical points here? 1 by 5 as well as 2. So to find the critical points, first we will find out where dy by dx or the derivative is 0. The derivative is 0 at x equal to 1 by 5. So this is one critical point. And which is the other critical point? Where the derivative does not exist. So that means the denominator of this expression will be equal to 0. So if the denominator of this expression is equal to 0, x minus 2 is equal to 0, that means x is equal to 2. So how many critical points we have in this case? 2. Now you find out the critical points for this function. Fx is equal to mod of 2 minus x divided by x square. Now find out what are the critical points for this function. See, 0 is a critical point because at x equal to 0 the function will not exist, but we are concerned about the derivative. So you first find the derivative. First find the derivative and see what are the points where the derivative is either becoming equal to 0 or the derivative does not exist. Now see, in modulus, you have to redefine the function first. You have to redefine. So what we'll do is fx is equal to 2 minus x upon x square if 2 minus x is greater than equal to 0, which implies 2 is greater than equal to x. Right? Now next, fx is equal to x minus 2 upon x square if 2 minus x is less than 0, which gives you this 2 is less than x or x is greater than 2. Now if you differentiate the two, what you will get? Let us differentiate this function f dash x. right? And what about the derivative of this? Now, what are the critical points in this case? 0 is a critical point. 0 is a critical point because at x equal to 0, the derivative will not exist. There's one more critical point. Now, what is that critical point? 2. Why 2 is a critical point? Because you will observe that at x equal to 2, the function is not differentiable. When you will take, because it is a mod function, the right hand derivative at 2 and the left hand derivative at 2 will not be equal. So, and what is the rule of differentiability? A function is said to be differentiable at a point when the right hand derivative and left hand derivative are equal. So, in this case, at x equal to 2, you will find out the derivative will not exist. Therefore, it is a critical point. And at x equal to 0, you will observe again the derivative will not exist. Now, what are the stationary points? Stationary points are those points of local maxima minima, where what happens? Where the tangent is parallel to x-axis, where the derivative becomes equal to 0. Those points are known as stationary points, right? Let us find the stationary point for the function fx is equal to sin x in the interval 0 to 2 pi. All of you try this. Find the stationary points for the function y equal to sin x in the interval 0 to 2 pi. See, every stationary point is a critical point. In stationary point, we don't take the points where the derivative does not exist. We only take the points where the derivative is equal to 0. Now, if you take the function y equal to sin x or fx is equal to sin x in the interval 0 to 2 pi, right? What is the derivative? Cos x. Now, when is derivative 0? When is cos theta 0? When theta is odd multiple of pi by 2. If you write general solution, it is 2n plus 1 multiplied by pi by 2, right? Now you substitute n equal to 0, what you will get? Pi by 2. And if you substitute n equal to 1, 3 pi by 2. And 5 pi by 2 will exceed 2 pi. So we have to take in this domain. So how many stationary points are there for this function? Only 2. Because if you draw the graph of y equal to sin x, you will observe that these are the only 2 points where the tangent is parallel to x-axis. So at these points, x is equal to pi by 2 and x is equal to 3 pi by 2. What will happen? The tangent will be parallel to the x-axis and hence the derivative will be equal to 0. Now you are clear with the stationary points as well as critical points. Next is absolute maxima. Absolute maxima. It is also known as global maxima or absolute maxima or the greatest value Now, what happens? How to find out what is the difference between the absolute maximum as well and the local maximum? What is the difference? A local maxima may not be a point of absolute maximum. Like for example, if we draw a graph like this, this is x is equal to a and this is x equal to b, y equal to fx, and the interval is, we are interested is closed interval AB. From A to B, A and B are included. Now, see, absolute maxima means in the given domain, which is D in this case, this interval A to B, right? We have to find the points where the value of the function is greatest. It can be maximum at other points also, but in the whole domain, it should be the greatest value. So how we'll define the points of absolute maxima? If the absolute maxima x equal to a will be a point of absolute maxima if f of a will be greater than or equal to f of x for every x belonging to the domain, like in this case AB. Is that clear to you? That is absolute maxima minima. See, you can have a local maxima. It may not be absolute maxima. If you see this y equal to fx, this is a point of local maxima. Now you have another point of local maxima here. So if you consider this point as C1, this point as C2, C1 and C2 are the 2 points of local maxima, because in the immediate neighborhood there exists a small interval around that point in which the value of the function at C1 is the greatest, in small interval around this point. So why C2 is a point of local maxima? Because there exists an interval, howsoever small it may be, in which the value of the function is maximum. See, if you go to the right, you will find that the value is less. If you go to the left, again the value decreases. So, but the maximum value we will find at the point C2, but it is not in the whole of domain in which the function is defined. Now function is defined from in the interval, closed interval a to b. Now in the whole interval a to b, you will find that these 2 points are the points of local maxima. These 2 points are the points of local minima. You can consider these points as D1 and D2, right? Now who will tell me which is the point of absolute minima first? You tell me which is the point of absolute minima? D1. So D1 is the point of absolute minima, because if you consider this point, throughout no other part of the curve goes below this. So D1 is a point of local minima, and it is also the point of absolute minima. Why it is a point of absolute minima, also known as global minima? Because it is in the entire domain in which the function is defined. And which is the point of absolute maxima here? B. X equal to B is the point of absolute maxima, because this is the highest or the greatest value which the function takes in the interval. Is that clear to you? The difference between local maxima minima and absolute maxima minima, right? Now similarly, this is x equal to a here is a point of absolute maxima. And what is the point of absolute minima? Some point, like we can say a is a point of absolute minima if value of a is less than equal to value of fx for every x belonging to the interval which we are considering. Next, please. Now again, absolute minima is there, it is clear to you. Now local maxima minima, the other term which we use for local maxima minima is relative maxima minima. Now how to find out the points of relative maxima minima, right? Now we'll study that first. See, one thing you must be clear is how to find the points. There are 2 tests which we conduct to differentiate, right? Which are the points of local maxima and which are the points of local minima. And there are certain points which are neither local maxima nor local minima. So those tests are known as first derivative test and second derivative test. Now the first step which we'll follow is to find out the points of local maxima minima is to find the critical points, right? We'll first find the critical points as I explained you, right? Now see, x equal to a, I am considering a point of local maxima. Local maxima. So what will happen? value of the function at A will be greater than or equal to value of fx, where x lies in a small interval around this point. So where x belongs to a minus h, a plus h. Is that clear? So this concept of neighborhood comes. In a small interval, it is making a maximum. See, if you look at this, there are points where the value exceeds this. The value at this point is greater than what we were having at x equal to a. Now suppose this is a function y equal to fx. This is the value f of a. Now this is some point which is not a critical point. This point is not a critical point. Neither the derivative at this point is becoming 0, nor the derivative is not existing. Right? It is not the critical point, but the value at this point alpha, f of alpha, is greater than that of a. But still this is a point of local maxima because we are just interested in a small interval around this point. So when we talk of local maxima, a function y equal to fx is said to be a point of local maxima at a if the value at a, f of a, is again greater than equal to value of the function fx, where x lies between a small interval around a. X belongs to a minus h to a plus h, where h is a positive quantity, tending to 0. Why we take h a positive quantity tending to 0? Because maybe we have a maxima in a very small interval. It can be a small interval and then the curvature can change. Now similarly, a local minima, again the definition is similar. A function y equal to fx is said to be a point of local minima if value of the function at a is less than equal to value of the function fx for every x around a, you can say, for every x in the neighborhood of a. So that's the reason x belongs to a minus h to a plus h, where h is a small positive quantity, or you can say h is positive tending to 0. So this is the definition of local maxima and local minima. Next, please. Now, what are extreme points? Extreme points are the points of local maxima and local minima. The point of, see, the common phrase which is being used to find local maxima and local minima is to find the extreme points, right? Now, method to find extreme points. Next. Yeah. Slightly higher. Now, first derivative test. First derivative test is we'll first understand the first derivative test, right? See, there is a necessary but not sufficient condition for points of local maxima minima. What is that condition? A necessary but not sufficient condition for points of local maxima minima is that if the derivative exists, it is equal to 0. Now, what is the meaning of necessary but not sufficient? A necessary but not sufficient. Necessary but not sufficient condition for points of local maxima minima is the derivative, if it exists, is equal to 0. Now, who will tell me the meaning of this necessary but not sufficient? See, if you have a point of local maxima or local minima, the derivative will either exist or no, if it exists, it will be 0, or it may not exist at all. For points of local maxima minima, I have told you at critical points you have local maxima minima. Now, what are critical points? Critical points are the points where the derivative will either be 0 or it does not exist. Now, so for every point, necessary means what? Necessary means at every point of local maxima minima, the derivative will, if it is existing, it cannot be any other value. If it is existing, it has to be 0. This is a necessary condition. But what do you mean by the condition is not sufficient? This condition is not sufficient. Sufficiency means if there is a function for which there is a point x equal to a, let us say, where the derivative is given to us is equal to 0, then you cannot claim with surety that that will be a point of local maxima or minima. This is the meaning of this condition is necessary, but it is not sufficient. Is that clear? The condition is necessary means at every point of local maxima minima, if the derivative is finite, if it is existing, it has to be 0. There's no doubt about it. But it is not sufficient because if the derivative in case of a continuous function is given to us is 0, we cannot claim it is necessarily a point of maximum. So if the condition is necessary, this way it will work, but reverse it is not sufficient. This information itself is not sufficient to say that if the derivative is 0, it has to be a point of local maximum minima. It may be a point of inflection also. Got it? Now what is first derivative test? X equal to a is a point of local maxima if the first derivative is 0. And next, what will happen? You will find the change of sign because of the curvature, the concavity changes at that particular point. Now see if this is a point of what? Local maxima. Now what is happening on the left hand side? This is x-axis, y-axis. This is a point x equal to a. This is the origin. What is the curve? See the nature of the curve on left hand side. It is an increasing function. On the left hand side, you will notice that when x increases, the value of, if x increases, the value of y also increases. This type of function is known as strictly increasing. So you will note this, that how this first derivative test works. Whenever you have a point of local maxima, let us say x is equal to a is a point of local maxima, you will observe that on the left hand side, very near to the point, you will find that the function will increase. And if the function is increasing, and if you draw a tangent, line on the left, in the immediate left of this point, you will find that the tangent will make an acute angle with positive direction of x-axis. So this theta is acute. So if theta is acute, tan theta will be positive. So the derivative at this point will be, a minus epsilon. This derivative will be positive. So this is the reason when we use first derivative test, x equal to a is a point of local maxima. If that particular point, the derivative, if it is existing, should be 0, because the curvature will change. On the left of it, the derivative will be positive. The derivative positive means the function will increase. And on the right hand side of a, see how we write f dash a plus epsilon. F dash a plus epsilon. What is happening? The curve reaches the maxima. At the point of maxima, this tangent will become parallel to the x-axis, and on the right, the tangent you will see makes an obtuse angle with the positive direction of x-axis. Obtuse angle means tan theta will be negative. Second quadrant tan theta is negative, so the derivative will be negative. So remember, the first derivative test we can use to find out the point of local maxima. At that point, the derivative will be 0. At the point where on the left hand side, the derivative will be positive because the function is increasing, and on the right hand side of that point, the derivative will be negative because it is decreasing. So what we'll do is x equal to a, you can write x equal to a is point of local maxima if the derivative at a is 0 and left hand derivative is what? Positive, and the right hand derivative is negative. See the sign of the derivative, it changes from positive to negative in case of a point of local maximum. And the reason is this: you have a geometrical interpretation to support your changes of sign. As you cross a point x equal to a from left hand to right hand side, the derivative will change from positive to negative. Now similarly you can find out, next please, x equal to a is a point of local minima. See, in case of local minima, what is happening? This is x-axis, this is y-axis. This is a function y equal to fx. I'm considering the same point, let us say x equal to a. Now here a is a point of local minima. What will be the tangent at this point? The tangent will be parallel to x-axis. So at this point the derivative will be 0. Now I am taking the case when the function is continuous and the derivative is existing, it will be 0. Now on the left hand side the function is decreasing, so the derivative will be, a minus epsilon will be negative. And on the right hand side the function starts increasing. So if the function starts increasing, what will be the derivative at the point a plus delta? It will be positive. So it is, so the derivative here will change sign from negative to positive for x equal to a to be a point of local minimum. Is that clear to you? Now what will happen if the derivative does not change sign? See, there are cases in which the derivative at that particular point does not is equal to 0. But when you see the behavior of the nature of the derivative, the sign of the derivative, it doesn't change. It remains from positive to positive or from negative to negative. So in that case, it is neither a point of local maxima nor a point of local minima. That is the case of point of inflection. This is known as point of inflection. You can consider a function, let us say y equal to x cube. You find out for fx equal to x cube, you find out whether you are having a point of local maxima, local minima, or a point of inflection. Fx is equal to x cube. Can you draw the graph of the function y equal to x cube? The shape will be like this. This is x-axis, y-axis, this is the origin. Now if we find the first derivative is equal to 3x square, right? And this derivative is 0 when x is 0. At x equal to 0, the value of the derivative is 0. But now if you apply this first derivative test, we will find that the sign of the derivative is not changing. See, now if you are taking 0, you take a point on the left, slightly on the left of 0. Let us take 0 minus 0.01. So it is minus 0.01, right? And the derivative will be what? 3 times square. So since it is being squared, obviously the sign will be positive. You consider a point slightly on the right. Let us take the point as 0.01, right? Again the derivative will be 0 plus h. H is taken as 0.01. So 3 times. See, we are not interested in the numerical value. We are just interested in the sign. So you will observe that the derivative is not changing sign. So x equal to 0, in spite of the first derivative vanishing, is neither a point of local maxima nor a point of local minima. This is what I was mentioning that it is not a sufficient condition. So you can have points where the derivative becomes 0, but they are neither of local maxima, they are nor of local minima. These are known as points of inflection. And you will see, you will notice at the point x equal to 0, the tangent is the x-axis itself. And a part of the curve is above the tangent and the other part is below the tangent. So in point of inflection, one part is above and the other part is below. So this completes our first derivative test. Whenever we have to find the first derivative test, these 3 points are there. Derivative changing, first derivative is 0. If the derivative changes from positive to negative, it is a point of local maxima. If it is changing from negative to positive, it is a point of local minima. If the sign is not changing, it remains from positive to positive or from negative to negative, it is a point of inflection. Right? Now let us solve one question. Find the points of local maxima minima and the corresponding maximum minimum values for the function fx is equal to x plus 1 by x. X plus 1 by x. What are the points of local maximum minimum? What you will do first, we'll find the first derivative. What is the first derivative? 1 minus 1 by x square. You can write it as x square minus 1 by x square. Right? So when you will equate this equal to 0, we'll get 2 points. 1 minus 1. What is the third point? Critical point if you are considering, right? For points of local maxima minima, you have to first find the critical point. Critical points are the points where the derivative is either becoming 0 or the derivative does not exist. So we will consider the third point 0 as well. Now let us check at x equal to 1 first. Find out what is happening at x equal to 1. What is the change of sign? See, if you substitute, see, denominator is always positive. Denominator being equal to x square will always be positive. Now, if you take the point x equal to 1, you take the left hand side, what you will observe? What is the sign? Left hand side means you have to find see, this is the derivative x equal to 1. I am finding out the sign of the derivative when x is slightly less than 1. Slightly less than 1, I can take 0.9. Right? Now, if you substitute 0.9 here, 0.9 plus 1 is positive. And 0.9 minus 1 is, and denominator we don't have to worry because it is square. It will always be positive. So the sign is negative. Now you take a point slightly on the right. So derivative is what? At a point, the sign of the derivative we have to find. It is 1.1, right? Now 1.1 if you substitute here, this is positive. And what is 1.1 minus 1? So x equal to 1, what you can claim? The same, see the change of sign. The sign is changing from negative to positive. Therefore, x equal to 1 is a point of local. Is that clear to you? And what is the local minimum value? Local minimum value you get by substituting that point in the original function. See, this is the point of local minima, and when you substitute x equal to 1 here, you get 2. This is the local minimum value. Point of local maxima, sorry, the point of local minima is 1, and local minimum value is 2. Now similarly you find the other case. What happens at -1? See what is happening at -1. So what is left hand derivative? What is the point slightly on the left of -1? You can take -1.1, right? -1.1. It should be very close to. So -2 should be avoided. You take -1.1. Now -1.1, if you substitute here, -1.1 plus 1 is negative. -1.1 minus 1 is negative. So the product is positive. Now if you take the right hand derivative, what is the value slightly on the right of -1? No, what point we should take? Minus 0.9. So 0.9 plus 1 positive, and 0.9 minus 1. So the change of the sign is from, in this case, positive to. So what is x equal to -1? It is a point of local maxima. This is a point of and what is the local maximum value? -2. Now children, you have noticed one thing, that the local maximum value is coming out to be -2 and the local minimum value is coming out to be 2. So in case of local maximum minima, it is not always true that the local maximum value should be greater. The local maximum value can be lesser because it is only in the small neighborhood or small interval around that point. So this is a classical example of a function in which the local maximum and local minimum value are the other way around. Local minimum value is greater than the local maximum value, and this can very often happen in these questions. And one more thing, there can be a short method to solve these questions. If I want to see the nature of the function at 0, how is behaving at 0? 0 is a point where the derivative is not existing. Maybe it is a point of local maximum minima. How you will reject it? 0 we have not considered. We have considered only the 2 points, 1 and -1, which were the stationary points where the derivative was vanishing. And where the derivative does not exist, that point I have not taken into consideration. So if you consider 0 as well, you will observe, see, this is the derivative, right? You substitute 0. If you see, denominator will always be positive. If you take a negative value, -0.1, so what will happen? This is positive and this will be negative, right? Now if you take a positive value slightly on the right side of 0, that means 0.1. So what will happen? This is positive and 0.1 minus 1, negative. Again negative. So at 0, there is some problem. It is neither local maxima is there, nor local minima is there. Now let us draw the rough sketch of this function and see how the maxima minima are formed. Now what is this function 1 by x? What is the function y equal to 1 by x? If you have to draw the graph of y equal to 1 by x, what is the graph? See, here we have sum of two functions, x and 1 by x. Can anybody tell me what will be y equal to 1 by x? It is a rectangular hyperbola in which the two axes, x and y axes, are the asymptotes. See, y equal to 1 by x will be like this. Here x-axis is one of the asymptotes and y-axis is also one of the asymptotes. Actually, what will happen? The function will come closer and closer to x-axis, and here the function will come closer and closer to y-axis, but they will meet at infinity, or they will not meet, right? This is the origin. Now, if you substitute x equal to 1, the value of y is also 1. So if you substitute x equal to 2, the value is half. When x is 3, value is 1 by 3. When x is 10, value is 0.1, 1 by 10. So this explains the reason for the x's being the asymptotes, right? And for negative values also, similarly, for negative values also, you will have a similar curve, but in the opposite quadrant. Here, this point can be taken as -1, -1, right? This is just a part of the function. Now, which is the other function? Y equal to x. What is the shape of y equal to x? It is a straight line passing through the origin. I write origin here. It will pass through 1, 1, and like this. Now, can you find the sum of these two functions? If I have to find the sum of these two, how will find? See, graphically also you can see this point at when x is equal to 1, when x is 1, this value is also 1, and the line is also passing through 1. So the point of intersection is 1, 1, and -1, -1. So what will happen if you find the sum when you substitute x equal to 1? 1 plus 1 will be 2. So what will happen? This will get doubled. It will be here. When you will find the sum of these two graphs. Now here, if you consider this point, right? This plus this. This is the value of y equal to x. And what is the value of y equal to 1 by x? This. So this part we have to add. So it will be somewhere here. You're getting what I am saying? I draw a vertical line. Now what is the value of y for this line, y equal to x? This is the value of y. Now to this, if I have to add 1 by x, what is the value of 1 by x? I want to just draw a rough sketch. So 1 by x will be this. So this part will come here. So the point will be somewhere here. You're getting my point? If you find the sum of this and this, because this is y equal to x, this is y for x, and this part is y for 1 by x. So when you will add up, so this particular part will be added here, right? And similarly on this side, if you consider this, right? What I'll do, I will add to this, I'll add this. So the shape will be somewhat like this. This particular shape will be the graph of y equal to x plus 1 by x. And you can observe that at the point x equal to 1, the curve is taking a turn. It is a turning point. And here the derivative is, the tangent is parallel to x-axis and the derivative is equal to 0. So this is a point of local minima. And local minimum value is, because if you substitute 1 here, the local minimum value is equal to 2. So sometimes these rough sketches, if you know and if you can draw, you can solve these questions very fast. And these are standard curves: rectangular hyperbola, straight lines, circle, ellipse, right? Now similarly, what will be the sum of these two? It will pass from this point, right? The shape will be like this. So this is -2, and this is the point of local maximum. See the curvature. What is this curve? These are known as concave up, and this is concave down. You know what is the, how to find the graph of a function is concave up or concave down? If the graph is concave up, the second derivative will be positive. If it is concave down, the second derivative will be negative. So second derivative is also very important. Like the first derivative gives us whether the function is increasing or decreasing. When the first derivative is positive, it is increasing. When the first derivative is negative, it is decreasing. When the first derivative is 0, the tangent is parallel to x-axis. And the second derivative tells us about the concavity, curvature, whether it is concave up or it is concave down. Next, please. Now comes second derivative test, right? Today our emphasis will be more on the concepts, and the next lecture will be dealing with lot many questions. Now comes the second derivative test. Now what is second derivative test? Second derivative test says that if fx is a differentiable function, it should be twice differentiable, right? Because we have to find second derivative on an interval I, and there's a point A belonging to I, right? See, this is a point A, this is y equal to fx, this is some interval I in which the function is defined. Obviously this point will be inside the domain, right? Now the second derivative test says to find point of local maxima, the first derivative should be 0, right, at that point, and the second derivative should be negative. I just explained you why the second derivative will be negative, because when the second derivative is negative, the function is concave down. So concave down is like this. So you will have a maxima at the point x equal to a, right? Is that clear? So second derivative test is simpler to apply, because you don't have to substitute values which are slightly less or slightly more. You have to substitute that particular point only. So the first derivative is equal to 0, and the second derivative, if it comes out to be negative, then it is a point of local maximum. Similarly, x equal to a is a point of local minima. Local minima if what happens? The first derivative is 0 and second derivative is positive. Remember these tests. Second derivative is positive, right? This is second derivative test. But second derivative test has a flaw. Can anybody pinpoint what we can see? First derivative is mathematically superior than the second derivative test. Can you make a guess? Why? Because if you look at the simplification or the solving numerically, it is better, because you have to generally the points of maximum minima sometimes are integral, sometimes trigonometric angles are there, so you don't have to take a value less than or greater than. But here you cannot find out point of inflection. See, if the first derivative is 0, second derivative is positive, it is a point of local minima. If the second derivative is negative, it is a point of local maxima. Second derivative positive, it is a point of local minima. But if the second derivative is 0, you can write the second derivative test fails. It fails to give us the, it is not applicable, you can say. It fails means you cannot differentiate between whether it is local maxima or it is local minima, and we cannot even reject. We cannot even reject. You're getting my point? We cannot even say that it is not a point of local maxima minima. Second derivative, if it becomes equal to 0, you can still that particular point at x equal to a, if I say the second derivative is 0, first derivative is 0, second derivative is also 0, right? Still x equal to a can be a point of local maxima, it can be a point of local minima, and it can also be a point of inflection. And you cannot even guarantee that it will be a point of inflection. So what we do is we revert back to first derivative test, right? Now next comes, next please. Yeah, this is what the note is. If the first derivative at a is 0 and the second derivative is also 0, we say the second derivative test fails. Now, what is points of inflection? I've already told you. If the first derivative does not change sign, then you can know it is a point of inflection. So in that way, the first derivative test is superior. The second derivative test can only differentiate between points of local maxima minima if it is continuous and twice differentiable, but it fails to tell us the point of inflection. So what is the nth derivative test? Let us now, all of you just try to find out. I'll give you a function fx is equal to x minus 1 raised to the power 4, right? You just find out the points of local maxima minima. For this function fx is equal to x minus 1 raised to the power 4, you find out the points of local maxima minima either using first derivative or second derivative. Any method you can apply. Yeah. Speak out. Yes, I can.
Okay, so in the graph of y equal to 1 by x,
Yes.
the average of x and y axis,
Mm-hmm.
you have said that y equal to 1 by x.
Yeah, y equal to 1 by x.
We touch x and y axis at infinity.
I was saying that when you draw y equal to 1 by x, you are able to hear. When you draw y equal to 1 by x, as you keep on taking larger and larger values of x, the curve will come closer and closer to x-axis. It will not touch. When I say it will touch at infinity, means the curve will never touch x-axis, and it will at every point further you go towards x-axis, this distance will continue to decrease. This distance will continue to decrease, and it is always possible to decrease this distance. Geometrically it is not possible, but these curve will not touch x-axis. Right now, what specific thing you want to ask? Is that clear to you? Touching at infinity means
Gx, f not g of x, and g not f of x. This type of graph, मतलब sin of log x या log of sin x या log of cos x, इस type के graph में कैसे sketch कर सकती हूँ?
see, you don't have to draw log of sin x and log of cos x. You have to know how is the graph of y equal to log x. You can draw y equal to sin x. You can draw y equal to mod of sin x. You can draw x equal to 2 by 3. You can draw linear equations. Logarithmic of trigonometric functions is not expected from you to draw, but the basic simpler functions you can draw and crack the questions. Is that clear to you?
Sir, and
Yes.
I have done problems maximum minimum on 2-dimensional.
Mhm.
So if I have problems of 3-dimensional, which have came in this exam in KBBY, if sphere के एक coordinate 0, 0, 0 point से एक sphere के ऊपर एक point लेना पड़ेगा और उसके लिए which is the minimum distance point वो निकालना पड़ेगा. तो मैंने 2-dimensional में maximum minimum की problems apply की है, पर 3-dimensional में क्या?
See, if you have 3-dimensional questions, in that you have to take partial derivative also, because if the 3 variables are involved at a time, you can differentiate with partial differentiation. Those are not to be done. Or you give me a specific question, then I can solve it.
Sir, given that the sphere is from x-axis it is its distance is 2, and मतलब इसके सेंटर के कोऑर्डिनेट पॉइंट है 2, 3, 5 और बोला है कि 0, 0, 0 पॉइंट से स्फीयर के ऊपर एक पॉइंट लेना पड़ेगा which is the minimum distance point from 0, 0, 0.
And what is the
Center 2, 3, 5.
no, the equation of the sphere should be given then.
Can you hear me, sir?
I can hear you, but then the equation of the sphere should be given. See the longest. What I am saying is, until unless the equation of sphere and the points are clearly defined, it is not possible to find the shortest distance. Or you can do it geometrically. Chaliye, thank you. Acha, now, yeah, this question. Local minima at 1. Now, what test you are applying? Neither the first derivative test works here nor the second derivative. This was what I was telling you, that at times, see what is happening here. Let us find out the points where the derivative is vanishing. First derivative. So f dash x is equal to 4 into x minus 1, 3. You equate it equal to 0. Now x is equal to 1 is a stationary point. It is also a critical point because this is a point where the derivative is vanishing. Now how to find it is a point of local maxima minima? If you find the second derivative, it will come out to be 12 x minus 1 square. Now second derivative is at x equal to 1, 0. So second derivative test fails. It is not able to give us a satisfactory answer. So we revert back to the first derivative. Now the first derivative, if you take the point slightly on the left, less than 1, like 0.9, will come out to be negative. And if you take a point slightly on the right, it will come out to be positive. So the derivative is changing sign from negative to positive. It is a point of local minima. Now suppose we want to use higher derivatives. We don't want to go back to first derivative. Then what is the concept? The concept is that suppose you find the second derivative and if it is equal to 0, you find the third derivative. You find the third derivative at the same point. Which point? X equal to 1. When you will find the third derivative at x equal to 1, what will be the third derivative? 24 into x minus 1. It will also come out to be 0. You find the fourth derivative. Now when you will find the fourth derivative at x equal to 1, it will be equal to 24, which is positive. Now just remember this, if the fourth derivative is positive, it will be a point of local minima. As we do with the help of second derivative, we can solve it with the help of fourth derivative, or for that matter, sixth derivative. Any even power derivative can tell you the fate of maxima minima. If any even power derivative is positive, it is a point of local minima, and if it is negative, it is a point of local maxima. But one thing you should be careful about is that all the derivatives prior to that should become 0. Is that clear to you? And you can even draw the, see, just few minutes back one student was asking me how you can solve it with the help of the graphs. Now this is the, at what point it will cut x-axis where y is 0 or fx is 0. This is 0 when x is 1. You know the shape of this. It is not parabola, it is 4th degree. So the shape will be like this. See what will happen, that it will rise faster. It will rise faster. But when the values are very small, when the values are less than 1, it will not rise faster. It will try to spread. So from 1 to 2, it will be slightly more broader. And then, right? Then it will rise very fast. At 5, what is the value? No, at 2. If you take the value 2, the value of function is 1. So it is 1 only, right? But when you take 3, what is the value? See the rise. So initially the graph of x4, let us say x4, it will be slow x square. But once it crosses 1 unit on both sides, it will tend to rise very fast. So the actual shape will be slightly broader near the base, and then it will go up like this, right? So, but we don't have to draw the exact graphs. Here, at least if you know that the graph is, the rough sketch is like this, you can just look at it and you can know that what is the point x equal to 1 is a point of local minima. So this whole these calculations you can avoid. Is that clear to you? Now, next, please. Properties of local maxima minima. Now, before this, just slightly before this. Now, methods to find absolute or global maxima minima in case of closed interval. Now, let us see if you have to find points of local maxima minima in a closed interval. You know how to go about it. The first derivative equal to 0 and the change of signs, or the second derivative test. But how you will find out for absolute maximum minima? First is absolute maxima minima in the closed interval AB. See, when you have to find absolute maximum minima for the closed interval AB, what you will do is you will find the first derivative, equate it equal to 0. You can find out the critical points, and besides that, you will also find out the endpoints and substitute in the function. Find out the values. So suppose, let us say, if there is a function y equal to fx, and you have to find absolute maximum minima, you find the derivative, equate it equal to 0, you get the point c1, c, d, and endpoints also you take. So at these particular points, x equal to a, c, d, b, you will find the value of the function. And then just by comparison, whichever is the greatest will be the point of absolute maxima. The one which is the minimum will be the point of absolute minima. You find the greatest as well as the least value just by comparison. You have to take critical points, and what else you have to take? The endpoints. But if the interval is open, then what you will do? If suppose there is a continuous curve and you have to take the open interval, then endpoints are not to be considered. Endpoints are not to be considered. So what you will do? You will find the only the critical points and then function and compare them. Let us take one question. Discuss the extremum of fx is equal to 2x, write down, 2x plus 3x raised to the power 2 by 3. Find out the points of local maxima minima. The question is, sphere have center 2, 3, 5. Find the minimum distance point from 0, 0, 0. The equation of the sphere is center of the sphere is 2, 3, 5. The minimum distance from 0, 0, 0. The equation of the sphere is not given. this is the origin. See the student, listen, the question has been posted here, the question which the student was asking. The question is, sphere has the center 235. Suppose this is the center of the sphere 235, right? And the minimum distance from origin, this is the origin. See, this is what I was telling you just a few minutes back, that the problem with this question is the question seems to be incomplete. Minimum distance of a point you cannot find from the sphere if the equation of the sphere is not given or the radius of the sphere is not given. Suppose the sphere is smaller, the radius is small, then the shortest distance will be this. And if as the radius keeps on increasing, the shortest distance will also what? The shortest distance will decrease. So in this problem, until unless the equation of the sphere or the radius of the sphere are not given, we cannot solve this problem. See, if the radius of the sphere is given, then it is possible for us to solve the problem, because see, if this is the radius of the sphere and let us say this is 7, we'll find this distance OC. We'll find the distance from the origin, from the center. Just by distance formula we can find this distance, and then we can subtract the radius of the sphere. We'll find this distance, which is the shortest distance. Otherwise, until unless, see, just knowing the center of the sphere is not defined, we cannot find the shortest distance.
Sorry, maybe mistake because the PVP में question आया था, उसको यही पता चला था, तो radius given था वहाँ पर some 10 centimeter या 20 centimeter ये.
And this is what I am saying, if the radius should be given. No, there's no problem. If the radius is given, then you can just, this point is the origin, this is the center. You can just use a distance formula to calculate this. It will be 2 square plus 3 square plus 5 square square root. You know this distance, subtract the radius. Then this is the shortest distance. Because shortest distance can never be like this. The shortest distance will be if you take the origin and join it with the center of the sphere. This distance will be the shortest, right? It's all right. Now I have given you a question. Who has solved it? X equal to, what's the time? Now if you are able to solve this, then I will skip this and move on to further questions. You are able to do this? Next. Now there are some properties of local maximum minima. I'll just mention the properties. Properties. Local maximum minima of a continuous function occur alternately. See, if there's a continuous function, you have a local maxima, then it will be followed by local minima, then local maxima. So they will be alternate because it is a continuous function. Second is, this we have already discussed, that the local maximum value can be greater than local minimum value. In case of absolute, it is not true. Absolute may, the absolute maximum is the greatest. It will always be greater than the absolute minimum. Third is, a local maximum or minimum value may not be absolute. It may or it may not be. And the next property, fourth, it is not essential that the extreme point is a critical point or a critical point is an extreme point. Critical points, extreme points means where the points of local maximum minimum. Now some questions will solve. Take up the first question. X is equal to 2 by 3. Fast. You tell me now which one of them is true. These questions have more than one correct answers. Now fx is x raised to power 2 by 3. You tell me whether it is a point of maxima, 0, 0, about origin. Origin is a point of maxima, origin is a point of minima, origin is a critical point, or there is no critical point. Which one of them are correct? Just this. Fx is x raised to power 2 by 3. Right? Let us find the derivative. 2 by 3, x raised to power 2 by 3 minus 1. Right? What is the point where the derivative is vanishing? No, it is not vanishing at 0. See, this can be written as 2 by 3 x raised to power 1 by 3. Derivative is never equal to 0. So you don't have stationary points. The point where at x equal to 0, the derivative does not exist. So critical point may, besides the point where the derivative is 0, we take the points where the derivative does not exist. The derivative is not existing. Does not exist at 0. But now consider this point 0. It is a critical point. So the correct option, C is a correct option, right? One of the correct option is C. Now, can you see the change of sign? How the first derivative is behaving? Why? We can take a cube root of a negative term. What is cube root of 8? Minus 8 is 2. And what is cube root of minus 8? Minus 2. Cube root of a positive number is positive and cube root of a negative number is negative. Why cube root of minus 8 is minus 2? Because minus 2 cube will give you minus 8. So if you consider this function, the derivative, first derivative, I want to know the behavior of the derivatives. I'll first take the left hand derivative and then I'll take the right hand derivative. So if you take the point less than 0, like minus 0.1, its cube root will be negative. And if you take a point 0.1, its cube root will be positive. We are just interested in the sign. So the derivative is changing sign from negative to positive. Is correct now? So there are two right answers. Now, second question. This second one is also very simple. Just see. Fx is equal to maximum value you have to find. So what is the derivative? Can you find derivative directly? No, you have to take log, right? So I can use y so that it is simpler. Log y is equal to 1 by x log x. It is actually ln basic. Now 1 by y dy by dx, right? Now if you simplify this, what you will get? Equate this equal to 0. So actually this y will come here. This y will not create any problem. Now log x is, and x is equal to e. So you can find the second derivative test. You see the sign and then you will find it is a point of local maxima. The second derivative will come out to be what? Negative. And what will be the maximum value? This value of e you will substitute in this function. So e raised to the power 1 by e. So this is a point of maximum. Try the third one, the global maximum value of this. Third question, you have to find the absolute minimum value. Absolute minimum value of this function. Fx is equal to x raised to the 4 minus x square minus 2x plus 6. What is the derivative? x4 minus x square minus 2x plus 6. So the first derivative is 4x cube minus 2x minus 2. If you take 2 common, I think you will be having 2 here. right? So by hit and trial, you can find out. If you substitute x equal to 1, right? Yeah, if you put x equal to 1, you get this 0. No, I am saying if you just substitute x equal to 1, the derivative becomes 0. So x equal to 1 is the point where the derivative is vanishing. Instead of solving it, you can just work it out like this. Or x minus 1 is one of the factors. You divide this by x minus 1, get the other factor, but those will not give any real value. The discriminant of that will be negative. So the only point where we have to verify is x equal to 1. And at x equal to 1, what is the minimum value? You substitute, you find the second derivative first. What is the second derivative? 6x square minus 1. So if you substitute 1 here, this is positive. So this is a turning point. And this is, since it is positive second derivative, at what point? At x equal to 1 is the point of global minima. So global minima, because in the whole interval, the local minima is also the global minima. And what is the global minimum value? You substitute 1 in this. So 1 minus 1, 4. So the correct answer is 4. C part. Next, please. Now see this question. Fx is equal to x minus p square plus x minus q square plus x minus r square. Then fx has a minimum at x equal to lambda. Then value of the lambda you have to find. What is value of lambda? B, I am afraid, is not correct. See, you cannot just, it might be right because there are just 3 options here. One of them has to be correct. But how to go about it? See, if you just use our method, find out in case of this question, you find the derivative. It will come out to be twice of x minus p plus twice of x minus q and twice of x minus r, right? I am finding the derivative. You equate it equal to 0. 2 will go. So 3x is equal to p plus q plus r. So just by finding the first derivative and equating equal to 0, you get x is equal to p plus q plus r upon 3. A part. And you can verify that here the second derivative at this point will come out to be what? Positive, because you have to find the point of minimum. So you can verify the second derivative will come out to be positive. Now question number 5th. Fn is equal to 20 minus n square, where n takes the value 1, 2, 3. It is not a continuous curve. In the 5th question, Fn is equal to 20n minus n square. And you have to find out Fn tends to infinity as n tends to infinity is the first option. Fn has no maximum. C part is maximum of this Fn is 100. D is none of these. Now which one according to you? And you have to apply simple basic rules. Question 5th is Fn is equal to 20n minus n square. N can take only natural numbers, 1, 2, 3 and so on. No maximum. See, if you look at this function, Fn is equal to, if you take n common, you will get n into 20 minus n. Right? You see, if you take n common, you will get n multiplied by 20 minus n. Now, if you put these natural numbers, see, if n is substituted as 1, if you substitute 1 here, this value I am substituting. What is 20 minus n? 19. So the product will be 19. If you substitute 2, next 18. So it will keep on increasing till both of them become equal. If I substitute n equal to 10, let us say I am substituting 9 and then finally 10. If I put n is 10, 20 minus n will be 10, this value will be 100. And if n is 9, 20 minus 9 will be what? 11, this will be 99. And after this again, the values will start decreasing. So it is just product of two numbers whose sum is given. You know, product of two numbers is there whose sum is 20. So the value will be maximum when x is, when n is 10. We have the variable n here. So the right answer is C. Now you try the next one, sixth question. See the function, question number 6, fx is equal to 3x square plus 12x minus 1, 37 minus x, right? Here you have x between minus 1 and 2. It is a piecewise defined function. Piecewise defined means for different intervals you have different functions, right? Now which one of the option is correct? Fx is increasing in minus 1 to, see, first option is just about the first function between minus 1 and 2. Fx is increasing. See, you can just differentiate. If you differentiate the function, you get 6x plus 12, right? And 6x plus 12 in that particular interval between minus 1 and 2 is increasing or not? When is 6x plus 12 positive? If you differentiate this function, 6x plus 12 is greater than 0 if 6x is greater than minus 12. So that means x is greater than minus 2. So when x is greater than minus 2, this will be increasing. So this first option seems to be correct. Now see the second option. Fx is continuous curve on minus 1, 3. Now to find out whether it is continuous curve on minus 1, 3, it is slightly difficult at the point. See, the function, separately if you look at these functions, they are continuous. Every polynomial is continuous in its domain throughout the whole real value. If the domain is not mentioned, every polynomial is a continuous function throughout R. Here you have some restricted interval. So 3x square plus 12x minus 1 is continuous. There's no doubt about it. 37 minus x being a straight line, and that also is a polynomial. This is also continuous. So what is the point where the continuity is at doubt, where we have to check continuity? The only point is at where the order relation is changing. So at 2 you just substitute and find out whether the value of function is same or not. If you substitute x equal to 2 in the first, what you will get? What is the value of fx? Is coming out to 35. And if you substitute 2 here, it is coming out to be 35. So at the end point of the interval, common end point, the value is same. So see, it is open. You cannot take 2. But then because the values are same, it will become a continuous curve. So the second one is also correct. Fx is continuous on minus 1, 3. Now similarly you find out the other cases also. What about C? See, it is better if you draw a rough sketch. Listen, let me just first find the derivatives. The derivative is 6x plus 12. And here the derivative will be minus 1. But more than a derivative, we can draw a rough sketch, right? So this is minus 1, 2, minus 1, 0, 1, 2, 3. Right? Now, what is the value at minus 1? If you find the derivative and you equate it equal to 0, you observe that minus 2 is the turning point. At least we know that turning point of this, it is a what? It is a parabola. So the turning point will be at minus 2. So minus 2 we don't want. It is not the part of the domain. But we know the function will turn like this. Right? And at minus 1, what will be the value? If if you substitute -1 here, the value will be 3, -12, -1. So this comes out to be how much? -10. So at -1 it will be -10. So it will go on like this. At 1, what will be the value? It will be, I think, 14. So 1 पर ये 14 होगा. And at 2, since that it has to take the shape of the parabola. So at 2, you told me it is coming out to be 35. So at 2, it will come out to be 35. So it will be like this, somewhat like this. And this value is 35. Now when you will draw the other part from 2 to 3, at 2 again the value is 35. At 3 it will be what? 1 less. It will come out to be what? 34. So the shape is like this. You're getting my point. So the shape of the function is like this. We have to draw from -1 only, right? Not at, we took the turning point, it came out to be -2. So this is the shape. Now from the shape, what you can conclude? From the shape you conclude, see, now you see the option. It is increasing in -1, 2. Yes, from here to here it is increasing. In fact, it is strictly increasing, right? If it is continuous on -1, 3, it is continuous, because the only point where we had doubt was the point where the order relation is changing. That was 2, and the value is same in both the cases. So it is also continuous. F dash x does not exist. So they should mention the point also. F dash 2, very good, because 2 is the only point where the derivative is not existing, it being a sharp point, because the tangent, unique tangent cannot be drawn at these points. So third option is also correct. F dash x does not exist at x equal to 2. They should mention F dash 2 does not exist. And then finally, fx has maximum value at x equal to 2. And that is also correct, because this is a point where the derivative is not existing, but it is a point of local maxima, because the derivative is changing sign from positive to negative. So here all the options are correct. Can we? Now try question 7 first. I think this is a simple question. You have to just find the first derivative, equate it equal to 0. You have to consider stationary points and the point where the derivative does not exist. You can take the point where the derivative is 0, and you can just take the point where the denominator is 0, and then you can verify. I think you can solve this. Question 8, you can try. For all real values, what is the maximum value of this expression? It is a rational expression. In question 8, you will find this is a rational expression. X square minus x plus 1 upon x square plus x plus 1. Now, how to go about it? You have to find the maximum value of this expression, right? Now let us consider this function as y equal to x square minus x plus 1 upon x square plus x plus 1, right? For all real values, you have to find the maximum value. So if I can write it as x square plus x plus 1 minus 2x upon this, so that this expression becomes equal to 1. This is 1, right? Now consider this function. Let us say this is the function fx. Now I am finding out the maximum minimum of fx. This expression will take the maximum value when this expression will take the minimum value. So we can just reduce it like this and find the derivative here. So what is the derivative? On simplification, what this is giving you? This expression. minus 2x square. 2 I have taken out. So minus 2x square minus x. So this will cancel out. So twice 1 minus x square upon this. Right? So what are the values with this function gx? I am taking 1 minus this function. Let this function be gx or fx, whatever. Fx. Now this point, this function fx will take maximum or minimum value at 1 and minus 1. So I am interested in that point where the value of this expression is minimum, so that when I can subtract, it becomes maximum. So what is the minimum value? What is the point at which the minima is there? See, if you consider this as, you find the factors. This is whole square, so the sign will not be determined by the denominator. So now if you take minus 1, right? If you take minus 1, you take a point on the left hand side of minus 1, minus 1.1. So this will be negative, and minus 1.1, if you substitute here, positive. So the sign will be what? Negative. And on the right hand side, if you take minus 0.9, minus 0.9, so this is positive, and this is positive. So derivative is changing sign from negative to positive. Therefore, x equal to minus 1 is a point of local minima. So you substitute this value. You substitute this value minus 1 here and find out the value of this expression, because the lowest value this will take will be minus 2 upon, if you substitute minus 1, you will get this only. So the value is 3. Maximum value is 3. And what about 9th question? Next, please. The number of solutions of the equation a raised to power fx plus gx equal to 0, where a is positive, gx is non-zero, and gx has a minimum value half. See, the minimum value of this expression gx is half. So how many solutions can this equation has? See, this equation will, how you obtain the solutions geometrically? The points where the curve cuts the x-axis. Now, a raised to power fx is an exponential function. Exponential functions are always positive. They don't take negative value. And gx, the minimum value is half. So gx is also positive. So this expression a raised to power fx being exponential will always be positive. And gx, the minimum value being half, is also positive. Sum of two positive quantities is always positive. So this particular expression is always positive. So it can never be equal to 0. So what are the number of solutions of this? 0. There is no solution, because this expression will never cut x-axis. It will always be above the x-axis. Now, next question. See this question 10. The number of values of x where the function fx is equal to cos x plus cos of root 2x attains its maxima. The points, this function, what maximum value it will take and at what point it will take. This is sum of two cos functions. One of them is cos x, other is cos of root 2x. What is the maximum value of this function? See, you can do this question in two different ways. Either you can do it with the help of the derivative, or you can do it just by trigonometry. See, if you apply the sum formula, what is cos c plus cos d? Cos c plus cos d is twice of cos a plus b by 2, right? And cos of now, when will this take the maximum value? The maximum value of cos theta is 1. And when the value is 1, when this expression is 0, cos 0 is 1, right? So This will be 0 at what point? When x is 0, this expression will be 0. And when x is 0, this expression will also be 0. So 0 is the only point which will make both of them 1. No other value can make it 1. You substitute any other value. If this is becoming, this expression is taking the value 1, this will not take the value 1. So what is the number of values of x? There is only one value. And if you differentiate, let us use our first derivative test. Cos x derivative is minus sin x minus sine root 2x into root 2. Now when this will be 0? What is the point when minus sine x will be equal to root 2 sine root x? Again, 0 is the only point which will make both of them equal. No other point will make both these trigonometric functions equal. So what is the answer? There is just one point, which is the point of maximum. And finally, 11th, x equal to minus 1 and x equal to 2 are extreme points of this function. Fx is equal to alpha log x plus beta x square plus x. Then which one of them is correct? Now extreme points means what? Extreme points means the derivative will be 0. So you find the derivative f dash x is equal to alpha by x. Log mod x is alpha by x plus 2 beta x plus 1. You substitute minus 1 and equate it equal to 0. You substitute 2 and equate it equal to 0. You will have two simultaneous equations. And those two simultaneous equations you can solve to obtain values of, those will be linear equations in alpha and beta. Solving that, I think B will be the correct option. Thank you. This one in fact is very simple. You know,